Okay. So yeah, I'll be going over the MONAI Bundles model and Model Zoo in sort of the Rise presentation format and walking through things. Um, and so the idea behind this is, same sort of thing for Google Colab. You have to make sure you switch your runtime to GPU. We'll be running some inference at the end of this, so it's always nice to have it in the GPU runtime for things. If you've already run previous notebooks in GPU and you switch runtime, you're going to have to go to manage session and kill your previous notebook to run this one. So just make sure, because it'll tell you that you can't have multiple sessions with GPU enabled. And so yeah, you can verify that you have your GPU up and running. And so going over what the MONAI bundle is, I think we've kind of mentioned it here and there throughout the presentation today. And the idea of a MONAI bundle is sort of we define sort of what a packaged model would look like that has all the information necessary for using the model, for retraining the model, for inferencing on the model. It can include the stored weights as sort of a pickled state dictionary, or you can have the torch script object, the Onyx object, and then any additional JSON, Python files, legal disclaimer, description, text files associated with it that might be useful depending on your particular model that you're working on. And we'll see kind of some differences and examples here in a little bit. And really the key benefit for this is that it helps sort of abstract the Python-based workflows into these structured configs, and it kind of helps everything be self-contained. It's readable and that you can go through and read the config file relatively easily, and you'll see sort of the one-to-one here in a moment of them. And that way you can kind of see what's going on in the actual config without necessarily needing the Python code behind it as well. And then it also abstracts things so that things like our AutoML or federated learning APIs can use the bundle and have a fairly consistent way of interacting with it, knowing, okay, I can just call the train config or the inference config, and it'll set everything up and run it with all the dependencies and all of the things necessary to integrate that model into some of those higher level wrapper pieces of MONAI. And so some of the key features is that the full programs can be structured in those config files, JSON or YAML, and then they can also be executed from the CLI. And we'll see an example of that here in a little bit. You can read that metadata and overwrite it both on the CLI and in the hybrid programming model where we actually load the objects into Python from the config files. And then we have some other nice things like macro text replacement, so you don't have to rewrite some of if you're reusing some of the same configurations over and over again, you can pull text from different places. You can refer to other Python objects. And then we also have ways so we can validate the metadata and everything, all the schemas kind of validated and making sure that everything's right. And then you can validate the network itself with input and output data as well. And also export it out to torch script. And so a typical bundle might look like this. So we have the model name. In the configs folder, we have different configs, and the metadata JSON has information like who was the author, what is this model doing, a license, anything else in the metadata JSON that you might think that might be worth including. Any notes on the model, the data that might be used, the data that was trained can be included in the metadata JSON. And you don't see it here, but typically we also have a lot of other config files there as well, like a train config, a multi-GPU training config, an inference config, an evaluating config as well. So that's where all of those files will go. Then you'll have your models folder, and then any additional docs. So the actual license text file, a README file if you want to describe or showcase what the actual model is doing. And then when we go dive into an actual config file, here would be sort of a small example of the basic syntax. So we want to define in JSON or YAML, and I'll show you both examples here of what a sample network architecture could look like. And here you see that we have a basic unit. And so we call this object here DemoNet. The target class is the basic unit in MONAI. We pass in some parameters for input, output, spatial dimensions, features, and that is in a JSON file there. Or you can see the equivalent of a YAML file example here. And We can also show that in a config parser way. So the way that we would actually use this in a config parser or in the Python object way of doing it, not the CLI way, is we would say load in our config parser, load in that demo config JSON that we saw before, and then we can say get out the parsed content. So in this case, we called it demonet from before, and that was the main object in the JSON file. We want to instantiate it. And then now if we ask Python to print the type of that object, we'll see that it's actually an instantiation of the basic unit class, just from calling config parser, loading those configs, and then saying instantiate this as a Python object for us. And the other nice thing is you can also tune the parameters with after you load things in. So in this case, you load in the config for demonet, and then you say, hey, I want to change the number of features and the layers for that. I can modify the array there directly. And then when I ask it to actually generate and instantiate the class, those are now modified parameters that are passed into everything. And so we'll go over a little bit of the syntax here because there are some kind of key characters and features and keywords that are used throughout this. And so one example would be the @ symbol. And so the @ symbol references another configuration value somewhere else. So in this case, we might be talking about pre-processing. So we're asking, go look at the pre-processing configuration. And then the hash sign means the nested substructure of that pre-processing. So we'll say we'll go to pre-processing, we want transforms, and then we want keys from there. Or we can use an integer to do indexing based off of what's in that substructure as well to pull it out. So maybe we want to know what's in the transform structure for somewhere else in the config file, and we can reference it this way of being able to reference the object and any sub things within that config file as well. The other thing you can do is have Python expressions that can evaluate. And so if you use a $, it's a character that indicates we want to evaluate this at runtime. So in this case, you could see print 42. So that wouldn't get evaluated until runtime when we actually instantiate the object for it. But the other nice thing about this is you can do something like the second one here, which is I for I in data list. So this is going to reference the data list object that's up above in the config. And then it's going to iterate over that in a for loop, but that for loop won't be run until actual runtime, but it'll be able to reference the data list that we suggested that it goes and loads. And so you can kind of create these nice dynamic ways of loading and having things at config time and then actually at runtime and mixing and matching these with the different syntax that we have available. And then you can also do this with imports as well, so that it makes the imports sort of globally available to all the other configuration sections, depending on where you actually need the import itself. Another example is macro text replacement. And so the nice thing about this is that you can replace things that are in different elements. So you might be able to take stuff that's in the current element. In this case, it's the demo config JSON, demonet, the input channels. So maybe you need that input channel as a replacement somewhere else in the configuration file. You can use this syntax for the %sign to say, go grab that value and replace it in this other component. That way you're not duplicating it, and you're essentially just using a variable to be able to macro text replace things within the config file as well to make it a little bit more modular. So you only have to change it in one place and not multiple places throughout the config file. And then you can also instantiate any Python class object that you want. So in this case, we say demo name _ target _ and that _ target _ is an instantiable type that we want to go out and run as a Python object. And then we can pass in any args after that. And so in this case, it'll go and call out to that my Python module class, instantiate that, make sure that it's passing in the parameters for it when we call out to it. And so any custom function or anything else that you need can easily be extended into this configuration. And then we also have the command line interface. So the command line interface is a nice way to utilize a few different commands that we have. So we'll say something like Python, MONAI bundle, and then whatever the command is. So if we want to run the training or multi-GPU training, it'll call out to that config file. And so long as the config files are correct and updated, it'll run everything. You may want to override some of those, and you can override, say, the dataset directory or where the model is located at in the command line itself by passing in some additional arguments as well. And we'll see some examples of that. So we've also mentioned the MONAI Model Zoo, and the reason why I bring it up here again is everything in the MONAI Model Zoo is a MONAI bundle. So every model on there has various configs in there that will help you retrain the model. Maybe it's multi-GPU training, maybe there's inference for it, evaluating for it. And so I encourage you to go take a look at it. I'll actually click here really quickly and show you guys the Model Zoo. And so in here, you'll see that there are, I think there's about 15 to 17 models now in here. And if you click on one of them, you'll see that it has details about what's actually in the model, different images of the overview, pre-processing, training, data, accuracy, performance. And then you'll also see some of those MONAI bundle commands that I just mentioned. So Python MONAI bundle run training, and then we can pass in those extra config files. We can overwrite config files that are in here as well to do whatever we need to do with those particular bundles. But the MONAI Model Zoo is a place where we have these already available, and people who want to contribute to the Model Zoo, maybe you have a model that is interesting that you want to share with the community, you can put in a request on GitHub to submit your model, and so that it can get posted on here into our Model Zoo. We're also looking at adding something called maps, which you'll learn a little bit later about in the MONAI deploy section, into the Model Zoo as well, which is sort of another layer above a MONAI bundle in a Docker container. And how do you kind of make it even more sort of self-contained and that it has everything available for it. And then there are some other niceties to that format as well. So we'll go over a quick example of a Spleen segmentation bundle. And so in our case, we want to set up some of our imports because we're going to go through and do both the hybrid programming and the CLI versions. And so we'll bring in our config parser, and we'll bring in some other visualization pieces that we want to use later on. And then we just print out our config to make sure that everything looks right. And now we can set up some other pieces. So we want to bring in our data set. So in this case, we're going to bring in the Spleen data set. And so we define a temporary directory. In that temporary directory, we say, please download the Spleen dataset and put it in that directory. And then in our case, if you're running this on Colab, which right now I'm running it on a local workstation, but I shrunk the dataset a little bit because the amount of RAM that you get on Colab, when I was loading some of the datasets in here to run everything, it started to run into out of memory issues. So this just kind of removes some of the data in there to make it a little simpler for things. And now we can actually download the bundle itself. And so we have a nice config here that is MONAI bundle download. We give it a name of the actual model, a version, and the directory of where we want the bundle to go. You can also use this to display all of the models that are in the Model Zoo. So it'll give you a list of all of them and give you some information about them as well. But in this case, we want to download that Spleen segmentation one. And that's going to bring everything that we need to run with our data set, and our configs and model that are in the bundle will give us what we need to do next. And so here's an example first of how, now that we have the data set and the bundle itself, how do we use that CLI to run the Spleen bundle? And in this case, we want to run, we're going to evaluate and run inference on the data to make sure that things kind of look right. And you'll see here that we run Python MONAI bundle run evaluating, and then we pass in this case, 3 different configs. There's a metadata JSON, an inference JSON, and a logging configuration conf file. And then we pass in the dataset dir. That dataset dir argument in the command line is actually a variable that's in the inference JSON, and we're overwriting it here to say, whatever value was in that inference JSON, it's not the same one that's on our workstation. Let's overwrite it with where it is in our workstation. And then for the bundle root, same thing. We downloaded it just up above. We said, where do we want this to be located at? And we're telling now that these config files, this is where the bundle root is, so that we can easily use it and override the data that we need that are from the config files. And so when we go through and we see the output here, you'll see that the dataset dir and the bundle root are updated to where the Spleen data is, where the model is. And then the other ones are references into that config folder of the actual bundle itself. But we can modify even more than that. And I'll show one quick example as well when I swap over to Colab as an example of what we can do with it. But when we hit enter on this, it'll run inference on all the different data that's in that folder and write everything out as sort of the output from the predictions from that model. And so if you're using, and if you want to sort of simplify it and use some of these models, all it really does take is your data, get the bundle, make sure some of the arguments might match up, or you can go and modify the config files themselves. And then you can rerun on another data set and do training and fine tuning on a different data set. So you have a lot of options, and it's a pretty easy way to get started because it's pretty minimal changes for things, and it makes it really easy to kind of reproduce the experiment that you might be doing with your bundle or model. Again, here's a full list of commands. I kind of showed you that already in the Model Zoo. Each particular model in there has different configs. So you have to kind of make sure that the config file is available if you want to do multi-GPU training. Not all of them have multi-GPU training. So you need to make sure that the config is available. But you can also make some of these configs. So you can go through and create your own config file for them. And you could say, I want a multi-GPU one, and modify that and create that. And we have reference documentation for that in the MONAI core documentation of how you might go about creating your own config files. The next piece I want to show is the hybrid programming piece. And so this is where we can kind of load all the components, and then we run inference on the network itself, and then we'll visualize the results just to make sure we're getting everything correct at the very end. So you saw a little bit about this already when I was going through the introduction to say that we had the ability to do hybrid programming, but we'll kind of go over it again. And again, here's what we try to make it as easy as possible. So as we start looking from the top down, we'll see that we're getting that torch device. Technically, that torch device line is in the config file as well, but we can choose to do that instantiation out here, not from the config, or we can decide to pull it from the config. Either kind of works. So you have the flexibility to pull in what you need and overwrite or not pull in whatever you don't need for it. Next, we go through and we join the path to get the inference JSON config file. We load our config parser and we tell it to read that inference JSON file. And then here we can start to override some of the variables that we need to override. And these are similar to what you saw in the CLI piece, which was we want to override where is the data set into the dataset dir. And we pass in that dataset dir to make sure that it knows where it's at. We want to give it a particular output directory, and we want to tell it where is the zoo directory. And so we can update the variables for each of those once we load in and parse the config file for it. And then we'll grab the model.pt file. And now we can actually tell it to instantiate objects of all of these things. So we'll say model config get parse content for preprocessing, network, and we'll also send that to device, to GPU, infer, post-processing, data loader. So now we have most of the pieces that we need for actually running through the network itself. And so we'll see an example here. So if I go through and I say model.load, we bring in the checkpoint for it, and we say where the device is for it, where we want everything to run, which is the GPU. We put it into eval mode. We can then say, give us an image from the data loader, which we instantiated up above or in the end of that last code block. Pass that image to device and run the infer on it with the network that we instantiated as well. So if I go back really quick, you'll see that we have our model, our checkpoint, our data loader, and the infer all here. And that's what we're using here in this next section. So data loader, checkpoint, device, images, infer, and model. And now we have that prediction written out into dpredict in that dictionary there. And what we can do is we'll take the images, we'll extract what we need from them, merge them together so we can show them visualized. And then we'll go through and we'll run over different slices within that image to show that it actually is going through, and I'll have to actually exit mode for Rise to show you all of this, but it'll print out every slice. And as we actually get to the segmentation piece, you'll see it here in the middle of the actual segmentation mask for the label. And then we'll see the blended version over here on the right. So you can see that the rest of it is sort of faded out a little bit. And then we see the actual segmentation. highlighted a little bit brighter in that blended version at the very end. But this is all from running that hybrid programming version of a bundle up above here. And so again, we just load the config, load the pieces. We have our data set that we want to run through it. And then we run through, and we could have done more data if we wanted to run through it. We could kind of do whatever you want with it at this point, how you would normally run it with a normal PyTorch workflow. But in this case, again, you're referencing that config file to make it easy, nice, and reproducible for being able to send your model out somewhere and people have all the information that they need to be able to rerun it. So that was the end of this one, this section. Do we have any questions? Let's see. Are MONAI bundles compatible with custom models? Yes, generally yes. And so really quickly, let me open up. So I mean, because I mentioned before that you could do any custom function that you want to call out to. So if you'll see an example like this one here, if you were to write your own custom network, you can just call it out the same way we would call it here. So you instantiate my custom network. The target is my custom network class, whatever parameters you might want to do to it, just like Ben showed it in the first notebook that we had of this is how we might create a wrapper class around it. So we have this nice modular network. We could instantiate that into this config file, give it some parameters that might be passed into it. Maybe it's always a 2D one and we want to default to 2D, whatever other things we might need to it. And then people can always override that as well later. But yeah, it should work well with any custom model or any custom function that you might want to integrate into the workflow for it. All right, I don't see any other questions right now. Right now, we're scheduled to take a quick break.